In 1 hour, a boat goes 11 kilometers along the stream and 5 kilometers against the stream. The speed of the boat in still water in kilometers per hour is. So this boat goes 11 kilometers along the stream in 1 hour. So we have been given the downstream speed. So downstream speed is equals to 11 kilometers per hour. And the same boat, if it goes against the stream, it travels 5 kilometers in 1 hour. So we have been given the upstream speed, that's 5 kilometers per hour. Now we have been asked what is the speed of the boat in still water, and there's a formula for that. So speed of the boat in still water, which is S, is equals to the addition of the downstream and the upstream speeds by 2. So SD plus SU by 2, and that's 11 plus 5 by 2, that's 16 by 2, and that's 8 kilometers per hour. So option C is the correct answer. A boat running downstreams covers a distance of 16 kilometers in 2 hours, while for covering the same distance upstream it takes 4 hours. What is the speed of the boat in still water? So the boat running downstream covers a distance in 2 hours. So the downstream speed is equal to 16 by 2 kilometers per hour, and that's 8 kilometers per hour. Now, while covering the same distance upstream, it takes 4 hours. So we can calculate the upstream speed, that's 16 kilometers by 4 hours, and that is equals to 4 kilometers per hour. Now this is very simple. What is the speed of the boat in still water? So the speed of the boat in still water is equals to the upstream speed plus the downstream speed divided by 2, and that's 4 plus 8 by 2. It is equals to 12 by 2, and that's 6 kilometers per hour. So option B is the correct answer. A boatman goes 2 kilometers against the current of the stream in 1 hour and goes 1 kilometer along the current in 10 minutes. How long will it take to go 5 kilometers in stationary water? So he goes 2 kilometers against the current in 1 hour. So the upstream speed is equals to 2 kilometers by 1 hour, that's 2 kilometers per hour. And he goes 1 kilometer along the current in 10 minutes. So the downstream speed is equals to the distance 1 kilometer upon the time, which is given in minutes. Let's convert it into hours. 10 minutes is 10 by 60 hours. So 10 by 60. So it is equals to 60 by 10, and that's 6 kilometers per hour. So now we have the upstream speed and the downstream speed. Let us calculate the speed of the boat in stationary water, which is equal to the addition of these speeds divided by 2. So 2 plus 6 by 2, and that's 8 by 2, and that's 4 kilometers per hour. Now we have been asked that how long will it take to go 5 kilometers in stationary water. So we have been given the distance and we have the speed. So speed is equals to distance upon time, and time is equals to distance upon speed, and that's distance is 5 by speed is 4, and this will be in hours. And if you solve this, you'll get 1 by 4 hours, and that will be 1 hour, and 1/4 of an hour is 15 minutes. So our answer is option C. A man takes twice as long to row a distance against the stream as to row the same distance in favor of the stream. What is the ratio of the speed of boat in still water and the speed of stream? You actually have two situations here, downstream and upstream. Let the distance traveled be x kilometers, and let the time taken to travel downstream be t hours. Now it is given that the man takes twice as long to row a distance against the stream as to row the distance in favor of the stream. So upstream the time taken is twice t hours. Now we have the time and distance, we can calculate the downstream speed. downstream speed is equals to x by t, and the upstream speed is equal to x by twice t. Now let us get to what is asked. The ratio of the speed of the boat in still water and the speed of the stream. So what is asked is s by s stream. Now we know the formulas. The speed of the boat in still water is equal to the downstream speed plus the upstream speed by 2 divided by the speed of the stream is equals to the downstream speed minus the upstream speed by 2. So what remains is SD plus SU upon SD minus SU. So let's put in the values. We have the downstream speed as x by t plus the upstream speed as x by 2t. In the denominator we have x by t minus x by 2t. So this is basically equals to 2tx plus xt by 2t square upon we have 2tx minus xt upon 2t square. So this get cancelled out. What we have remaining is 2tx plus xt, that's 3tx, divided by we have 2tx minus xt, that is 1tx. So these two get cancelled out. What remains is 3 by 1. So the ratio of the speed of the boat in still water and the speed of the stream is 3:1. That's option B. A man's speed with the current is 15 kilometers per hour and the speed of the current is 2.5 kilometers per hour. What is the man's speed against the current? So the man's speed with the current is 15 kilometers per hour. So this is actually the downstream speed, right? Now the speed of the current is 2.5 kilometers per hour. So this is basically the speed of the stream. Now what you want is the man's speed against the current. So what you want is the speed traveling upstream. Now you know the formula of the speed of the stream, which is equal to the downstream speed minus the upstream speed by 2, and that is equal to, we know the downstream speed, 15 minus SU, that's what we have to find, divided by 2, which is equals to S stream. S stream is 2.5. So we have 15 minus SU is equals to 2.5 times 2, that's 5. Therefore the upstream speed is 15 minus 5, that's 10 kilometers per hour. So we have the correct answer, option C.